On the right-hand side, we have a bunch of expressions that are just ratios of different information given in these two diagrams. And then over here on the left, we have the sine taken of angle MKJ, cosine of angle MKJ, and tangent of angle MKJ. And angle MKJ is this angle right over here, same thing as theta. So these two angles have the same measure. We see that right over there. And what we want to do is figure out which of these expressions are equivalent to which of these expressions right over here. And so I encourage you to pause the video and try to work this through on your own. So assuming you've had a go at it, so let's try to work this out. And when you look at this diagram, it looks like the intention here on the left is this evokes the unit circle definition of trig functions, because this is really this is a unit circle right over here. And this evokes kind of the SOHCAHTOA definition, because we're just kind of in a plain vanilla right triangle. And so just to remind ourselves, let's just remind ourselves of SOHCAHTOA, because I have a feeling it might be useful. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So we can refer to this, and we can also remind ourselves of the unit circle definition of trig functions, that the cosine of an angle is the x-coordinate, and that the sine of where this ray intersects the unit circle, and the sine of this angle is going to be the y-coordinate. And what we'll see through this video is that they're actually, the unit circle definition is just an extension of SOHCAHTOA. So let's look first at x over 1. So we have x. X is the x-coordinate. That's also the length of this side right over here. Relative to this angle, theta, that is the adjacent side. So x is equal to the adjacent side. What is 1? Well, this is a unit circle. 1 is the length of the radius, which for this right triangle is also the hypotenuse. So if we apply the SOHCAHTOA definition, x over 1 is adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent over hypotenuse, that's cosine. So that's going to be, this is equal to cosine of theta. But theta is the same thing as angle MKJ. They have the same measure. So cosine of angle MKJ is equal to cosine of theta, which is equal to x over 1. Now let's move over to y over 1. Well, y is going to be the length of this side right over here. Y is going to be, let me do this in the blue. Y is going to be this length relative to angle theta. That is the opposite side. That is the opposite side. Now, which trig function is opposite over hypotenuse? Opposite over hypotenuse, that's sine of theta. Sine of theta. So sine of angle MKJ is the same thing as sine of theta. We see that they have the same measure. And now we see that's the same thing as y over 1. Now for both of these, I use the SOHCAHTOA definition, but we could have also used the unit circle definition. X over 1, that's the same thing. That's the same thing as x. And the unit circle definition says, well, this point, the x-coordinate of where this, I guess you could say, the terminal side of this angle, this ray right over here, intersects the unit circle, that by definition, by the unit circle definition, is the cosine of this angle. X is equal to the cosine of this angle, and the unit circle definition, the y-coordinate is equal to the sine of this angle. We could have written this as, instead of x comma y, we could have written this as cosine of theta, sine theta, just like that. But let's keep going. Now we have x over y. We have adjacent over opposite. So this is equal to adjacent over opposite. Tangent is opposite over adjacent, not adjacent over opposite. So this is the reciprocal of tangent. So this right over here, if we had to, this is equal to 1 over tangent of theta. And we later learn about cotangent and all of that, which is essentially this. But it's not one of our choices, so we can rule this one out. But then we have y over x. Well, this is looking good. This is, y is opposite. X is adjacent relative to angle theta. Adjacent. So this is the tangent of theta. This is equal to tangent of theta. So tangent of angle MKJ is the same thing as tangent of theta, which is equal to y over x. Now let's look at j over k. So j over k. Now we're moving over to this triangle. J over k. So relative to this angle, because this is the angle that we care about, j is the length of the adjacent side, and k is the length of the opposite side. So this is adjacent over opposite. So this is equal to adjacent over opposite. Tangent is opposite over adjacent, not adjacent over opposite. So once again, this is a reciprocal of the tangent function, not one of the choices right over here. So we can rule that one out. Now k over j. Well, now this is opposite over adjacent. Opposite over adjacent. That is equal to tangent of theta. This is equal to tangent of theta, or tangent of angle mkj. So this is equal to k over j. Now we have m over j. M over j. Hypotenuse over adjacent side. This, of course, is equal to the hypotenuse. Hypotenuse over adjacent. Well, if it was adjacent over hypotenuse, we'd be dealing with cosine, but this is the reciprocal of that. So this is actually 1 over the cosine of theta, not one of our choices here, so I'll just rule that one out right over there. But then we have its reciprocal, j over m. That's adjacent over hypotenuse. Adjacent over hypotenuse is cosine. So this is equal to cosine of theta, or cosine of angle mkj. So we could write it down. So this is equivalent to j over m. And then one last one, k over m. Well, that's opposite over hypotenuse. Opposite over hypotenuse. That's going to be sine of theta. So this right over here is equal to sine of theta, which is the same thing as sine of angle mkj, which is the same thing as all of these expressions. So this is equal to k over m. And we are done.